number 9. We will study here fluids in motion. Up till now we have studied fluids which are steady or stationary. We call that branch of physics as a hydrostatics. And here we consider the fluids in motion. We have to study fluids in motion. Then branch of physics which deals with the study of fluids in motion is called as hydrodynamics. Hydrodynamics, it is the branch of physics which studies about the fluids in motion. And up till now we have studied hydrostatics. See here difference, statics and dynamics. Fluids in motion, they are studied and we call it as a hydrodynamics, and fluids are steady, we studied, that is we call it as a hydrostatics. Now here I hope you understand the difference between hydrostatics and hydrodynamics. And in notes there is a small printing mistake. You change that, hydrostatics is printed but you write hydrodynamics. Now we consider here when fluid is in motion. Suppose fluid moves through a pipe or tube. So I consider here, suppose I will draw here a diagram. Suppose I will draw a diagram like this. I will draw a diagram. Suppose all these fluid moves like this on these lines. We get the number of lines like this. Straight lines are, we consider fluid moves like this through this pipe. Suppose A is the area, okay, area of cross section of the pipe. We consider this is the flow tube, and these lines we consider they are flow line. Now here we consider different definitions. First, steady flow. What is meant by steady flow? Here measurable properties, that is pressure, velocity at a given point or at all points is constant. Then that flow is called as steady flow. That means measurable property, that is pressure or velocity of a fluid at a given point is constant at all time. So it is called a steady flow. Now next one, flow line. It is the path of an individual particle in moving fluid. Path of an individual particle in a moving fluid. This is the flow line. Next one we consider streamline. It is a curve whose tangent at any point in the fluid is in the direction, we consider is in the direction of velocity. That means tangent at any point. Suppose we draw tangent here. It gives the direction of velocity. This is the streamline. Next one, flow tube. It is an imaginary bundle of flow lines bounded by an imaginary wall. What is flow tube? Imaginary bundle of flow lines. Imaginary bundle of flow lines bounded by imaginary wall. This is the flow tube. Next one, laminar flow. laminar flow or streamline flow. Laminar flow or streamline flow. Here, laminar flow or streamline flow, it is a steady flow. This is a steady flow in which adjacent layers of a fluid move smoothly. Steady flow and adjacent layers move smoothly over each other. This is the laminar or streamline flow. And next one, turbulent flow. It is a flow at very high flow rate. Flow at high flow rate, and it is not steady flow, and pattern changes continuously. This is all about different definitions we have used in fluids in motion. I will explain again. Steady flow means here pressure or velocity is constant at all points at all time. Flow line means path of an individual particle in a moving fluid is called as flow line. Streamline flow. Streamline, it is a curve. It is a curve whose tangent at any point in the fluid is the direction of velocity. We call it as a streamline. Flow tube, imaginary bundle of flow lines bounded by imaginary wall. Laminar flow or streamline flow, steady flow and adjacent layers moves smoothly. Turbulent, it is turbulent flow means having high flow rate and its pattern changes continuously. This is all about different definitions we used in the fluids in motion. Now we will consider next article here. Difference between streamline flow and turbulent flow. Difference between streamline flow and turbulent flow. Suppose I will write here streamline flow. I will write here turbulent flow. Now I will explain one by one. Streamline flow and turbulent flow. Suppose first point, smooth flow and with velocity smaller than critical velocity. I will write here smooth flow and velocity smaller than critical velocity. This is the first point. It is a smooth flow with velocity smaller than critical velocity. Here first point, irregular and unsteady flow. Irregular and unsteady flow with velocity greater than critical velocity. This is the first distinguishing point. Now second, velocity at any point in a fluid is constant. At any time velocity is constant. At any point velocity is constant. Second point here, velocity does not remain constant from point to point or at any time to time. Velocity changes. This is about the turbulent flow. Now we will consider third point here. Third point, two streamlines can never intersect. That is, they are always parallel. two streamlines can never intersect, that is they are always parallel. Here we write third point. Here at some points fluid have rotational motion. Rotational motion, or we consider eddies. Now fourth point, all layers are parallel to the axis of tube. And here fourth point, fluid tube loses order and particle moves in random direction. These 4 points, they are distinguishing points between streamline flow and turbulent flow. Again I will explain. Here we consider this flow is smooth flow whose velocity is less than critical velocity. This flow is irregular and unsteady flow whose velocity is greater than critical velocity. Here velocity is constant at all points and at all time. Velocity does not remain constant in case of turbulent flow. Two streamlines can never intersect, that is they are parallel, always parallel. Here we consider there is number of intersections. It consists of rotational motion or eddies. All layers are parallel to the axis of tube, and here loses order and particle moves in random direction. This is all about distinguishing between difference between streamline flow and turbulent flow. I hope you understand all this. Now we will consider next article, critical velocity and Reynolds number. Critical velocity and Reynolds number. The velocity beyond which a streamline flow becomes turbulent is called as critical velocity. Streamline to turbulent, this conversion, and that velocity, a velocity after which streamline flow becomes turbulent, that velocity is called as critical velocity. According to observing Reynolds, critical velocity is given by Vc is equal to Rn eta upon rho into d, where Vc critical velocity, Rn Reynolds number, eta coefficient of viscosity, eta is coefficient of viscosity, rho density of fluid, and d diameter of tube. This is direct relation. This is equal to Rn eta upon rho d, and therefore we write here Rn is equal to Vc into rho d upon eta. Rn is a pure number. This is a pure number. Rn pure number. Okay. And Rn we consider here. Rn is less than 1000. Then flow is streamline flow. Then Rn is greater than 2000. Flow is turbulent, and Rn 1000 to 2000. Then unsteady flow. This is all about, that is flow of the liquid. I hope you all understand this. In next period we will start next article, that is viscosity. Thank you.